Welcome, welcome back to this third technical session of the first day of international webinar on intelligent optimization techniques and their real-life applications. Now I would like to introduce our next speaker, Dr. E.H. HOUSSEIN, Associate Professor of Computer Science, Vice Dean of Postgraduate Studies and Research Affairs, Faculty of Computers and Information, Minya University, Egypt. Founder and Chair of the Computing and Artificial Intelligence Research Group. Professor Dr. E.H. HOUSSEIN received his PhD degree in computer science in 2012. He is an associate professor at the Faculty of Computers and Information, Minya University, Egypt. He is the founder and chair of the Computing and Artificial Intelligence Research Group in Egypt. He has more than 100 scientific research papers published in prestigious international journals in the topics, for instance, meta-heuristic optimization, artificial intelligence, image processing, IoT, and its application. Professor E.H. HOUSSEIN serves as a reviewer of more than 60 journals. His research interest includes WSNs, IoTs, AIs, bioinformatics, and biomedical, image processing, data mining, and meta-heuristical optimization techniques. Now, I would hand over the stage to Dr. E.H. HOUSSEIN. Sir, please. You can share your screen.
Okay. Where I want to see where okay.
Yes, sir. It is visible.
Yes. My screen is appear at you.
Yes, sir. Yes, sir.
Yes. First, I would like to thank you and the webinar community. Dr. Narendra Sen is my friend, and he who invite me to be a speaker in this event. So I will enter the subject directly. My research points is the meta-heuristics, so I will introduce my talk in natural and inspired algorithm, taxonomy, and some open problems and the application. I will introduce the algorithms classification, taxonomy, and the alternative overview, and the search process, and how this algorithm can be solved some problems called optimization problem. And I will set some open research problem So then I will concluded my talk by the conclusion. The computer science and the computing and the information and the engineering, all the research in these fields now, they used meta-heuristic methods to solve some problems. Uh, all, all of them, all of them need an algorithm to solve their problem. I will present now two important things. The first is what is the meaning of nature-inspired algorithm, and how these algorithms solved the problem, and how the researcher use this algorithm to solve the problem. Everyone from this community uses this algorithm to solve this problem. What is the meaning of nature inspired algorithm? Are meta-heuristic methods. Are meta-heuristic methods mimics the nature inspired and used to solve optimization problem. Nature inspired algorithm is inspired from the nature behavior, and we will see that in the next slides. What is the meaning of optimization problem? Optimization problem is every real world problem can be defined as an optimization problem. I will set some example to see that. For example, in machine learning, there are many classifiers such as SVM. SVM classifier contain some parameter. We need to set the optimal value for this parameter. This is an optimization problem. In deep learning and neural network, there are some parameters such as learning rate and the number of layers in the neural network. These parameters need to be set the optimal value or the near optimal value for this. This is an optimization problem. In the electrical engineering, such as PV, there are some parameters for PV solar radiation cells for a single diode, triple diode. These parameters need to be set the optimal value. What is the algorithm? Which is the algorithm can set this or can decide or can determine this optimal value. In the wind speed for the renewable energy, there are some parameters need to be set as the optimal value. So any real world problem can be converted as an optimization problem. After that, can be solved by the meta-heuristic algorithm. Algorithms classification. So there are many way to classify the meta-heuristic algorithm. In this slide, you can see 4 categories: swarm intelligence, bio-inspired, physics, and other. Some swarm intelligence based algorithm. This is the famous and popular category used by the research. Swarm intelligence concerns on the collective emerging behavior of multiple interacting agents who follow some simple rule. So you can look at the picture in the screen. Some birds, some fish. This to be some algorithm to be a swarm, you must have a group, and the group have interacting agent with it with their member. Otherwise, not a swarm. You can categorize this as another way. I want to make to say a swarm intelligence means a group and have interaction. Group of birds, group of animal, a group from the nature, and this group interact with each other. This is the first group. The second group, bio-inspired but not swarm. يبقى you can say bio-inspired but not swarm. It is not a group. No interaction between the members. So you can say about this category bio-inspired algorithm, not a swarm, but such as differential evaluation and biological behavior. You can see some flower valuation and other example. The third category is the physics and chemistry category. The source of inspiration here is depend on the physics law, such as Newton, Henry Gas, Archimedes, and some other chemistry such as water cycle algorithm and so on. The last category is otherwise. Not a swarm, bio-inspired, not physics. This is the reset of the algorithm can be set in the fourth group. We can set other algorithm. In the next, I will talk about the swarm intelligence because it is the most popular and widely used by the research community. Swarm-based algorithm usually sharing information. This is I present that from Menes. Swarm intelligence means group and interact between each member. Self-organization, learning during iteration, multiple agent. This is the characteristic of the swarm-based algorithm. I wanted to conclude that is the meta-heuristic algorithm can be categorized into four groups: swarm, bio-inspired, physics and chemistry, and the other. There is other alternative views such as the taxonomy. You can see the fourth. These some examples from swarm, bio-inspired, and some example of the algorithms in each category. To know, there are more than thousands of methods in the meta-heuristic published in papers in this today. And each day or every day, a new algorithm is published. And a new improved algorithm from this category is improved and published today. This means that this is a hot topic. Every researcher need a method used to solve this problem. This method is called a meta-heuristic method. And a meta-heuristic method is classified, as you say, in the slide, that in the taxonomy, into four categories: swarm, bio-inspired, physics, and other categories. I wanted to say, look at another interview, another taxonomy. You can say meta-heuristic. This is a picture summarize the taxonomy of the meta-heuristic. Another view is introduced by Mirjlili in paper in the whale optimization algorithm paper. He classified the meta-heuristic algorithm into evaluation-based, physics, swarm, and human-based. As you see in this picture, meta-heuristic, evaluation algorithm, physics-based, swarm-based, and other human-based. And this is an example for each category. This is a picture from the paper of the whale optimization algorithm. Proposed by Mirjlili in 2016. To conclude the previous slides, I want to say we talk about a meta-heuristic algorithm. What is the meta-heuristic algorithm? Meta-heuristic algorithm is divided into four categories. We can say evaluation algorithm, physics, and swarm, and human. We can say swarm and physics and bio-inspired and other algorithm. What is the aim of this algorithm? This algorithm is used to yes. I will send the presentation to Dr. Narendra, and he will send for you. Okay. I want to say I mean by we, the researcher in the computing and information community. We use the meta heuristic algorithm to solve the problem. I want to say everyone hear me now. He work to solve a problem, so he need a method. This method recently is a meta heuristic method. So what is the problem? Everyone have a problem. Can model or define this there is problem, real world application problem, to be an optimized problem to solve it by a meta heuristic method. Please thank. You can categorize the meta heuristic algorithm from our point of view. And this is some authors classified as it is. You can classify it as you say. I said that four major categories: swarm, bio-inspired, initial science, natural phenomena. This four category from my paper published in 2020. How this algorithm work? You can think how this algorithm work to know how to solve your problem. First you must know how this algorithm work. All the nature inspired algorithm, all the meta heuristic algorithm use two phases: exploration and exploitation. Exploration mean global search. Exploitation mean local search. What is the meaning of exploration? Exploration mean finding promising region of the search space. I wanted to say, think about the society of the whales or some animal. Some animals live in a space. This is called population space. Population space. This space they finding promising region in the search space اللي هو population space. This mean exploration. After finding the promising region in the search space, they finding the locally find an accurate approximation in the global. This mean exploitation. يبقى meta heuristic او nature inspired algorithm process divided into two phases: exploration and exploitation. Exploration mean global, exploitation mean local. Exploration the first, then the exploitation. All the algorithms have the same two phases. If you say there exist more than 1,000 methods, all the thousands methods have these two phases: exploitation and exploration. Exploration the first, then the exploitation. And if you think now to define or propose the new algorithm, then you must how these two phases will be, and you must define the two phases and the balance between them. Okay. What is the mean of local optimal and global optimal? Local minimum function is a point where the function value is smaller than at nearly point. Global optimal is where the function is smaller than and other visible points. This means any algorithm must avoid to valid local optimum. When you think to design or propose a new algorithm or to improve in the existing one, this means that you think that this algorithm avoid to fall on the local optimal. If the algorithm fall in the local optimal, then the best or optimal solution can be reached. So you must need, if you think now to improve an existing algorithm, you must you need to say what is about the exploration and exploitation phase and the local optimum. This is the three drawbacks you must look at when you study a new algorithm. If this algorithm falling to local optimal, this means that you need to find a method to improve this algorithm to avoid to fall in the local optimum. And you can say that is a novel or a new improved for the existing one. Several research work by this way. And if you look at the paper, published paper, you find now, today, a new algorithm X is published, and the next you find an improved for it. This means that the researcher study the behavior of the algorithm and they discover a drawbacks. One from the three, four. Exploration and exploitation phases, local optimal, convergence. The algorithm must be good in the three phases, three steps. Exploration and exploitation is balanced, avoiding local optimal. Convergence is optimal. If any algorithm have a drawbacks from the three, you can improve the existing one by another or by alternative one. And if you look at, and if you look at the published paper, you can see many version variant from existing one. Then you must know all the meta heuristic stored randomly. So if we run, you can find a new result because the algorithm is stored randomly. I said an example about the WOA, whale optimization algorithm, start with random solution. And in this run, next run start with random solution, and then the third run start with random solution. So in the three, you will find a different result. So there is no algorithm can find the optimal solution, but can find the near optimal solution, not the best solution. Single solution, population based approaches. You must know there is some algorithms or some approach single solution, such as simulating, leaning, guided search, iteration, and all these algorithms work to now is population based approach, such as PSO, genetic algorithm, evaluation algorithm, swarm intelligence. All these categories are defined as a population-based algorithm, depend on a group and a population-based working. Today, there is some algorithm. We need to hybrid two algorithms with each other to take advantage from X and advantage from Y to merge or combine or to find a good one. May want to mimic a meta heuristic algorithm with a machine learning classifier for classification tasks, for regression tasks, such as if you want to if you have a data set, biomedical data set, and you need to classify a disease, for example, you need a classifier such as SVM. So meta heuristic plus SVM, this is a mimetic algorithm. We need to hybridize two meta heuristic with each other. This is a hybridization, or mimic to a meta heuristic with a machine learning classifier, a mimetic algorithm. This brainstorm generally speaking, nature algorithm can solve application. Saying you have a problem and you need to solve it. Is this meet-heuristic algorithm can solve, or is one meet-heuristic algorithm can solve all the problem? I think the answer is no. If a one meet-heuristic algorithm can solve all the problems, so why we need a new algorithm? If you search in the internet now, you will find today a new algorithm. So I will say not all algorithms can solve all problems. So we need a new one and improved one. All the algorithm cannot find the optimal solution. You can apply X algorithm and Y algorithm, and you can find X better than Y in this problem. But in another problem, you can find Y is the best of X. Why? Because the meet-heuristic algorithm is dependent on the problem. You can find an algorithm is better for this problem, but not better for another problem. So we need a new algorithm, and we need to improve this algorithm. You can say, I will, in the second part, I will talk about the optimization. I introduced some knowledge about meet-heuristic algorithm. Meet-heuristic algorithm for category work to solve a problem. What's the problem? Any problem can be modeled as optimization problem. Or some application engineering industry and the other topics can be solved or can be used can be used by meet-heuristic algorithm. If you say, you can see computer science, engineering, medicine, commerce, all these fields used meet-heuristic now. Why? To solve their optimization problem. So this is the optimization problem. Any real application can be modeled as, so you can solve it by meet-heuristic algorithm. Even what does this mean? Engineering problem, a mathematical problem, any benchmark problem, data set, and etc. You can model this problem as this form. So this is an optimization problem. So the meet-heuristic algorithm can solve this problem. What is the problem? What is unique? What's unique? I need the optimal value or near optimal value for some parameters from this problem. Or meet-heuristic algorithm can find that. I need the feature selection, the most significant feature from the data set. Meet-heuristic algorithm can do that. I need the optimal value for some parameters for engineering problem or energy problem. Meet-heuristic algorithm can do that. So change your problem to be an optimization problem and set in this form. This problem can be a continuous optimization, discrete optimization problem, constrained problem, one or many objective. Your problem is single objective or multiple objective. You need to select one or two. This deterministic optimization or statistic optimization. This is the types of optimization problem. What do you need? All the algorithms published today solve single optimization problem. So if your problem is multi-objective problem, so you need to enhance it or adapt the algorithm or the method to be solving the multiple objective problem. Question. I need to hear from you why we need more algorithms. If you have more than 1,000 algorithms, Why we need more? Global optimization method and local search. What is the meaning of? Continuous optimization problem here important in yes. The answer of this question, the first one, why we need more algorithms? Because no free lunch Ethereum uh, has proven that no optimization technique for solving all optimization problems. As I say from minutes, that we have several optimization problems, and we don't have one method can solve all. So we need every day a new algorithm because we have unsolved problem. We have unsolved problem. And you can say this the reset of the questions. I want to say, I want to look with you on some open research problems, such as you can, if you want to search or if you want to work in this, you find a proper balance between exploration and exploitation. If you have a meta-heuristic algorithm, swarm or bio-inspired or physics or whatever, you can study the behavior of the exploitation and exploration first. Then you can finding the promising region of the search space. You can hybrid two algorithms to select the advantage of one and the second and make or create your own. You can improve existing algorithm because may have some problem or drawbacks, such as you can say when you read or open a new algorithm, you can search for three phases. واحد, balanced between exploration. Is this algorithm have a balanced has a balance between exploration and exploitation? Is this algorithm avoiding falling in local optima? Is this algorithm don't have a convergence speed? If the algorithm have don't meeting this three, so this algorithm have drawbacks. So you can search how to solve this problem in the algorithm, and you can improve the existing one. You can using some methods, operators or strategies such as chaotic, transfer function, offset, quantum computing to improve the existing algorithm. These methods can use to improve the existing one. Optimization such as feature selection, parameter setting, test function, engineering problem, novel algorithm. You can create a new one if you have the source of inspiration. If you have the source of inspiration, but take care to create a one, and then you can find this is published because the algorithm is huge, more than 1,000 or more than. So يبقى novel algorithm you can create one, but you must study all the existing one because to find this is algorithm not created. Not you can look at the main objective, the objective function of the algorithm. You can look at the local optima. You can study the optimization problem. You can global optimal, possible solution, and so on. In the last source mentioning here that we can swarm هي subset من البايو inspired, هي subset من النيتشر inspired, هي subset من الميتا heuristic. Optimization is everywhere. Optimization is everywhere. All the applications now using meta heuristic to solve this problem. In most generic terms, the main source of inspiration is nature. All the meta heuristic algorithms are inspired from the nature. For example, animal, birds, fish, physics law, chemistry law, and so on. Exploration is a process of visiting and new region of search space. Exploitation is the process of visiting this region of a search space within the neighbor of previously visited point. Exploration and exploitation is the important two phases in any algorithm, and they must balance it. Local optimum must avoiding falling into local optimum. Convergence speed must be obtained. This is some biography. In the last, I want to thank the webinar community, and I want to thank the all members um, here. And if there is any question, I will can be answer that, and I will share with you the slides. So thank you for very, and I will be with you. Thanks.
Thank you, sir. Thanks a lot for sharing your precious thoughts and spare your time from your busy schedule and present with us. Thank you, sir. Now it's time to take
Thanks.
the queries from the participants. If you have any queries, please, I like to ask the host to please allow all the participants to unmute themselves so that they can ask their queries. Or you can write it in the chat box also. Yes, any queries from the participants? Yes,
Okay,
please.
thanks. Okay, thanks.
Not sure.
I will share with you I will share with you the presentation, and I will
Sir,
set my contacts if you would like to contact me after that.
sir, there is one question in the chat box. Please see to it. To mean different optimization are suitable based on the nature of the problem. One of the
What?
person is to
Can
mean
you?
yeah. To mean different optimization techniques are based on the nature of the problem. They are asking this type of question.
Okay.
Yeah.
There are many different meta-heuristic algorithms. So there are many different optimization problems, such as in computing in machine learning field. There are an optimization problem such as feature selection, such as optimization the classifier parameters, SVM parameter, deep learning rate, and so on. In the engineering, there are many optimization problem, electrical engineering, and so on. In medicine, data set classification, regression, this is an optimization problem. So there are many optimization problems. All real world application problem, if you can define as an optimization problem, so you can solve it by meta-heuristic method. So meta-heuristic method is a method, black box, need input, it's do some processing, and the output is the near optimal solution you need. If you look at the research published in this uh, years, you can see that all the engineering, medicine, commerce, and so on need used this algorithm to solve this problem. How do you place in biological data like bioinformatics? Bioinformatics is, I see some question highlighted now, such as bioinformatics. Bioinformatics is a data set, and you need to classify a disease such as cancer, such as COVID-19. There are thousands of papers published in COVID, more than 80 from computer science community, because they apply the meta heuristic such as optimization algorithm to classify or to predict the COVID-19. How? This is a bioinformatic dataset, and this is a optimization algorithm. They applied that using طبعا classifiers such as SVM or deep learning. يبقى this is the author deploy or propose a mimetic algorithm, optimization algorithm, hybrid with classify, applied on COVID-19 COVID-19 dataset, and the result is a classification or the prediction. Okay.
Thank you, sir. Thanks a lot. Now I request Dr. Satyavir Singh, sir, convener of this webinar, to thank sir and to present the certificate of appreciation to sir.
Okay. Thank you, Shukran.
Thank you, Professor HOUSSEIN.
Yes.
Thank you very much for sparing your valuable time. Punjabi University really feels honored to have you as a resource person in international webinar on intelligent optimization techniques and their real life application. Thank you very much.
Thank you. Thank you.
Thank you, sir. As this was our last session of our first day of international webinar, I would like to thank everyone for their participation. Thank you. Have a nice day. Thank you. Yes, one more thing. We share the feedback form link in the chat box. Please give us feedback for this first day international webinar.
The feedback
Share the
form
link.
yes, feedback form is also being shared on WhatsApp, WebEx, as well as YouTube channel. Professor Usman, do you want to say something?
Yes, sir.
Please.
Thank you for the presentation.
You are not audible. Please set your mic. Dr. Usman.
Can you hear me?
Oh, no. Audibility is very less.
Yeah. Good morning. Thank you for the presentation. Can you hear me now?
Yes, sir. Now you are audible.
Okay. Please, I don't know if the presenters, they can be able to share the slides with us so that we can be able to go through it. Hello?
Usman?
Hello?
Hello, Usman?
Yes, sir, I'm saying that the presenters the doctors, the professors, they can be able to share the slide with us.
Yes, I will ask everybody to share their PPT and we will share it on WhatsApp.
Okay, thank
We
you.
will definitely share each and every material.
Thank you so much, sir. Thank you.
And anything else? Is there anybody who want to share his views? If there are no queries, then we call it a day. Thank you very much for joining with us.
Thank you very much. We're so grateful.
Thank you, sir. Thank you very much for your impressive and excellent presentation.
You are welcome.